Hello everybody! Today we are going to have a look on Kirchhoff's laws. Why do we need Kirchhoff's laws? Because they can help us calculate how the information, current, voltage spreads across a circuit. If we have a simple circuit like in the image below and we need to find out the current that flows in this circuit, then it is very simple. We know Ohm's law and we have to apply it to find the value of the current. We have here two examples. For the first example, we have a power supply and only one resistor. Here we have to apply only Ohm's law to find the value of the current. So when we apply the formula, then we will have 5 volts divided by 500 ohms, so it will be 10 milliamperes. For the second example, we have a power supply and 3 resistors, 2 in series and 1 in parallel. First time we can reduce the series connection R1 plus R2 and we will obtain 2 kilo ohms. Now it remained only a parallel connection, and after we reduce it, we will have an equivalent resistance equal with 1 kilo ohm. Then we apply Ohm's law and we will obtain 5 volts divided by 1 kilo ohm, it will be equal 5 milliamperes. But if we have a more complicated circuit, a multi-loop circuit like in the following image, then we can no longer apply these methods, parallel and series, for finding the current value. We need Kirchhoff's laws. These laws help us to calculate these types of circuits, electrical network. But until seeing which these Kirchhoff's laws are, let's see what an electric network is. An electric network is a circuit composed from network branches, network nodes, and net mesh. A network branch is a wire with electric components placed between two successive nodes. A network node is the point where at least 3 branches meet, and a net mesh is a closed loop consisting of at least 3 network branches. Now that we have this information, let's see Kirchhoff's law. Kirchhoff's current law is the first law, and it says that the total current entering a node is exactly equal to the current leaving the node, as it has no other place to go except to leave, as no current is lost within the node. So, if we add all the currents which enter in one node and all the currents which exit the node, then the result will be 0. In other words, if we add all currents which enter in a node, then we will have the same value of current which will exit that node. Kirchhoff's voltage law is the second law and says that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop. If we add all voltages from the closed loop, then we will obtain 0. In the next video, we'll present each law and we'll make some exercises for a better understanding. See you next time.